morning to my dear students. Today we discuss about the structure and properties of fiber in regulation 2018. The structure and properties of fibers you have to study. Already you study the fiber science in these regulations. So this is the advanced versions of the fiber science subject, that is structure and properties of fibers. So first of all, we see what is meant by fiber. Fiber is also defined as a fine strand of tissues of plants or animals or any synthetic material drawn out into very slender filament and subsequently cut into required lengths. These materials should have the sufficient length, pliability and strength. A fiber is a material which is several hundred times more than its thickness or diameter. So next we see the before going to the structure and properties of fiber subject, we have to see classifications of the different fibers. So we know the different classification of fibers, then only we can easily understand the subject clearly, and also we can uh, identify the different fibers and what are the fibers that will be continuously frequently used in the domestic market and also in international market, and how the fiber will be behaved, and what are the materials used to manufacture the fibers. Like that we know, mean we identify that properties only of fibers only we can understand the subject and also understand the concept very clearly. Okay, so natural fiber is fiber is classified into natural fiber and man-made fiber and artificial fibers. Natural fiber is classified into animal and vegetable fiber, and from the sericulture we can classify into silk fiber from hair, wool, animal hair and horse hair and camel hair. Vegetable fiber from seeds, cotton. From the inner bark, flax, stem, jute, rami and flax. So next, from leaf, abaca, sisal, banana fiber, and from fruit, coir fibers. And man-made fiber is classified into artificial and synthetic. Artificial fiber is 100%, not 100% a man-made fiber. 50% man-made fiber, 50% chemical will be used. For that, viscose rayon and polynosic rayons and acetate rayon, triacetate, protein fiber and tensile fibers are used. In synthetic fiber, it will be classified into acrylic fiber, 100% man-made fiber. It is classified into acrylic fiber, chlorofiber, elastane fiber, fluorofiber, monoacrylic fiber, polyamide fiber, polyester fiber, polypropylene, polyethylene, polyurethane fiber, trivinyl fiber. Next, the inorganic fiber is classified into please wait. Inorganic fiber is classified into mineral, that is the uh, from metals and from boron from others, and glass fiber and carbon fiber and others, asbestos fibers. Next we see about the what is mean by the length to width ratio. Length to width ratio of the fiber material must possesses adequate staple length and adequate width of the fiber, then only it will be converted into yarn. For production of yarn, we should have an adequate staple length and adequate width of the fiber. So the fiber length and fiber width is very important for converting the fiber into yarn. So length is 1000 mm means width is 1 mm. So 1000 times the length will be in higher compared to that of the width. For example, the fiber which is used to manufacture into yarn, it will having a 1000 mm in length and 1 mm in width. Then only it is easily converted into fiber, and adequate properties like physical, chemical and the thermal properties will be accumulated in that particular fiber. which having a length to width ratio is accurately or precise manner. So next we see about the different types of fibers image. This is cotton, jute, flax, square, flamp. These are the images of the various fiber. Because you are in the class, so it will be you are new to our textile. So you are in position to understand or to see the image of these fibers. Next, what is meant by stable fiber? Stable fiber is approximately definite in length, that is known as stable fiber. Indefinite in length is known as filament, that is 1 to 4 inch is approximately. The length of the stable fiber may be 1 centimeter to many, minimum 1 centimeter, minimum 100 is used to manufacture the fiber into yarn. Filament is our continuous length more than 5 inch. Filaments are manufactured by ourselves because it is a man-made fiber. We can use the melt spinning, dry spinning, wet spinning technique. We can use this in different techniques. So it will be easily converted into higher length or lower length according to our requirement or the customer requirement. We have a cutter which is kept below the spinneret or the chamfer. We can give signal to the sensor to the, we can attach the sensor to the cutter. The sensing will be happening every 100 or every 200 it will be cut. So the fiber will be cut according to the settings we kept, and the sensor will be act in the melt spinning or dry spinning or wet spinning. It is easily cut. So according to the customer requirement, we can manufacture the fiber with different length in filament fiber, but not in the case this is certainly different in case of stable fiber. In stable fiber, we can fix the length. So 1 centimeter means 1 centimeter. So all the fibers are in uniform in length. So man-made fiber is filament fiber or stable fiber, but the natural fiber is only in the stable fiber, because it is naturally according to the natural climate or climatic condition it will be uh, manufactured. This is stable fiber and the filament fiber. So stable fiber according to the manufacture, according to the climatic condition and the yield of the soil present in that particular land, the length of the fiber will be varied from country to country and state to state and the soil to soil. So this is, you understand, okay. um, so minimum is 25 or 15 is enough to manufacture the length, manufacture the fiber into yarn. So depending upon the type of the fiber and the climatic condition and the varieties of yield we use, and varieties of plants that will be planted in the land of farmer land, the fiber will be get, length will be get varied in natural fiber. But instead a man-made fiber, the stable fiber is constant in length. Next, some important properties of fibers, that is the fiber length, fiber strength, and fiber flexibility, fiber cohesiveness, fiber uniformity, bulkiness, flexibility. These are the major essential properties required for the fiber. And other physical properties is physical shape, specific gravity, luster, moisture content and moisture regain, elastic recovery, breaking extension, resilience, elongation, and some of the thermal and chemical properties: resistance to thermal behavior, resistance to moth, resistance to bacteria, resistance to fungi. These are the chemical properties of fibers. Resistance to chemicals such as acids, solvents, alkalis, etc., and resistance to biological agents, and resistance to sunlight, and resistance to environmental condition. Thermal properties according to the type of the chemicals present in that particular fiber or cellulosic material present in the natural fiber, the thermal behavior will be vary. Glass transition temperature and the melting temperature and the flow temperature, that is known as flow thermal behavior of fibers. According to the type of fiber, either it will be a man-made fiber, it will be having very high thermal properties, and also strength is also very high, but the strength as well as the thermal property is very low for the natural fibers such as cotton, wool, viscose rayon, and regenerated fiber is viscose rayon, and natural fiber is wool, silk. The very strength is moderate and the thermal property is very low. Next we see what is meant by strength. The unit of strength is gram per denier or text per denier or uh, the strength of any material is determined by the strength of breaking strength, that is the tenacity, which expressed in force per unit cross sectional area. So or the load by linear density, area of cross section or load applied divided by the linear density. சரியா? Oh, this is the unit of that tenacity or strength or modulus. They all are stream unit stress, that is gram per denier or gram per tex. So that is the known as the unit. So tenacity is breaking load divided by linear density or mass per unit length. Next, the tenacity of raw cotton is 3.0 to 4.9 gram per denier, and jute is 3.0 to 5.8 gram per denier, and flax is 7.7 gram per denier, and rami, silk, wool are followed by the polyester. It will having the around, we see the polyester and is very high strength because it is a man-made fiber. 100% the natural material is used to manufacture. Next, what is meant by flexibility, cohesiveness? Cohesiveness is the flexibility somewhat more or less equal to the flexibility. And if you take a human hair, it will not return to its original position. The cohesiveness property is very poor for human hair, because when whatever we change the shape of the human hair, it will not return to its original position. It will not converted into that positions we change, because it having very poor cohesiveness, it return to its original position. Automatically it will return to its original position. Flexibility means what is the fiber should be sufficient pliable, then only it will be easily converted into yarn when it passes through the rollers or the machines, weaving machines of heavy beating will be given by the sleigh or the any mechanism, that will be enough to retain their originality and their properties. So the flexibility is very important property. Next we describe the similarity in length of the fiber which are spun into yarn. To make a good quality of yarn, it is very important that the fibers must be similar in length and width in spinning quality and flexibility. There is no problem in producing uniform man-made fiber, but for natural fiber, uniformity is difficult to achieve. So for natural fiber, it is essential to blend many batches in order to manufacture good quality of yarn and fabrics. Next, physical shape. The shape is very important, and specific gravity is also a density. Density is very important. That is the, you see the asbestos fiber, this having very high density in the fiber family, and polypropylene and polyethylene is very low density in the fiber family, around less than 1. The asbestos is 2.10, and that is the gram per cubic centimeter. The unit of density is gram per cubic centimeter. Next, luster. Luster is very important property. Luster, we improve the luster, it will having very high tensile strength. Moisture regain is also very important property. So it will good moisture regain, will accept dyes and chemicals easily and with low regain. So the exhaustion of dyes is in the dye bath is very 100% very neatly that will be done. Again, the relation between fiber strength to moisture content is important consideration in the evaluation of fiber behavior. Some of the fibers are stronger when it is wet than the drier. Some weaker Some of the fibers are weaker when it is wet than dry. So no change. There will be a maintenance of textile product are influenced by strength and regain relationship. Okay. Okay, these are the topic we see in the next class or next hour. Huh? Okay, thank you very much. Thank you.